Next, I will show how to apply the two proportions Z procedure to test a statistical claim about two population proportions. Consider the following example. A group of researchers wants to know whether men are more likely than women to contract a novel coronavirus. They surveyed two random samples of 350 men and 340 women who were tested and found that 70 men and 36 women in the samples tested positive. At 1% significance level, test the claim that men are more likely to have the novel coronavirus than women. First, let's note that the sample proportions are 20% and 10.59% for men and women respectively. Also, the pooled proportion is 15.36%. Now, let's identify the statistical claim that needs to be tested. The claim is that men are more likely to have the novel coronavirus than women. It is not obvious, but the claim is about the population proportion of positive tested men being greater than the proportion of positive tested women. So we can symbolically express the claim as P1 is greater than P2, or equivalently as P1 minus P2 is greater than 0. Since the claim is about the population proportion, we will use the two proportions Z procedure. Before we begin the two proportions Z procedure, let's check if all necessary assumptions are satisfied. The samples must be assumed simple random and independent. If not, then the results of the test are invalid. The central limit theorem must be applicable, so the number of positive and negative responses must both be greater than 10 for both samples. We will use the following template to perform the hypothesis testing. In step 1, we will set up the hypothesis. In step 2, we will identify the significance level. In step 3, we will find the test statistic using the formula. In step 4, we will perform either the critical value approach or p-value approach to test the claim. In step 5, we will draw the conclusion, and finally in step 6, we will interpret the results. Since our claim P1 minus P2 is greater than 0 is in the form of an inequality, we are going to set it up as an alternative hypothesis. Therefore, the null hypothesis, which is always in the form of an inequation, must be P1 minus P2 equal to 0. So the test is right tail. Step 1 is complete. The significance level can always be found in the statement of the problem. In our case, it is 1%. Step 2 is complete. The test statistic can be computed using the formula. In our case, the test statistic Z0 is equal to 3.427. Step 3 is complete. Next, we will test the hypothesis using two different approaches, the critical value and the p-value. In the critical value approach, we construct the rejection region. In this approach, we need to know the significance level alpha and the type of the test. We draw the rejection region under the standard normal probability density curve according to the type of the test. So right-tailed test will have the rejection region in the right tail. The region must have the area equal to the significance level 1%. The left boundary of the region is the critical value Z 0.01, which is equal to 2.326. So the entire region can be described as all the values to the right of 2.326. In p-value approach, we compute the p-value. In this approach, we need to know the test statistic and the type of the test. We find the p-value using the standard normal probability density curve according to the type of the test. So in the right-tailed test, the p-value is the area to the right of the test statistic. Symbolically, it can be expressed as probability of C being greater than 3.5 3.427, which is equal to 0.0003, which is effectively 0. Next, we're going to decide whether to reject or not reject the null hypothesis. In the critical value approach, we must check whether the test statistic is in the rejection region or not. Our test statistic is 3.427, and it is to the right of the critical value of 2.326. Thus, it is in the rejection region. In the p-value approach, we must check whether the p-value is less than the significance level or not. Our p-value is effectively 0, and it is less than alpha. Both tests suggest that we do reject the null hypothesis in favor of the alternative. Next, we are going to interpret the results. Interpretation. Under 10% significance level, we have sufficient evidence to suggest that men are more likely than women to have the novel coronavirus. The hypothesis test is complete. I just showed how to apply the two proportions Z procedure to test a statistical claim about two population proportions.